Hello, my name is Dimitar, and today I'm going to talk about how to refactor an orchestrator method that is also a decision maker. If you don't know what I mean by orchestrator and decision maker, please read my blog post on the topic here. So here's an example of a method where orchestration and decision making are all mixed together. I found this method in someone's project on GitHub. It is part of a larger service class, but I extracted only the method and the relevant dependencies so that it's easier to fit on one screen and not concern ourselves with other unrelated code. So let's see what this method does. It first adjusts the value of a start and size parameters to not be less than 0. Then it goes and gets some feeds from a feed repository. Then it loops through these feeds, and based on the feed type, it calls on the appropriate repository to get a feed entity. Then it adds the feeds into the feed manager. Then it goes and it gets the items from the feed manager and it returns them to the caller of the method. Just by looking at this method, we can split it into 5 parts. First part are the first two if statements, this one's here. The second part is getting the feeds from the repository and also initializing this feed manager. A third part is looping through the feeds that we got from the feed repository, and based on the type of the feed, we take a decision which repository to use so that we get an entity. Then the fourth part is adding the entity to the feed manager. And the fifth final part is getting items from the feed manager and returning them to the caller of the method. Now let's look at these 5 parts in terms of which ones are the decision makers and which ones are the orchestrators. The first part here, the if statements, are clearly a decision maker. The second part, the call to the repository and also instantiating of the feed manager, are orchestrators. Then we have the switch statement, which is a decision maker because it makes a decision based on what's the feed type. It decides which repository to call with the feed item ID to get an entity. Then we have 2 other method calls, which we can count as orchestrators. The feed manager, add feed item, and getting the items from the feed manager. At this point, we have a decision to make. Do we want to make this whole method a pure orchestrator and extract the decision-making parts out, or we want to make it a pure decision maker and supply it all it needs from the outside as parameters? Usually, when it's an existing method in a larger class, we would go the first route and extract the decision-making out, simply because the class we are working with is already wired with its dependencies. An object that has external dependencies must be an orchestrator. So with that in mind, we are ready to start refactoring. Okay, let's extract our first logical unit. That is those first 2 if statements, these ones here. Looking at them, we see that all they're doing is they're applying some business rules where if start is less than 0, we must make start equal to 0. If size is less than 1, we make size equal to 5. What is interesting about these parameters is that they seem related. What I mean by related is they come in together, they're manipulated pretty much together, and then they're used together here. So they're pretty much screaming at us, hey, we want to live together. And how do we marry parameters that want to live together? We use refactoring called extract class from parameters, like this. Not only it created our new class for us, but it also went and took care of all calls to this method by replacing the arguments that we had before with an instance of our new class. Okay, now let's go and move all related logic to our new class. Now let's do the same with size. Now let's go and remove this logic from here. And now we see that when we need the size, we will get the right size, and when we need the start, we're gonna get the right start. Let's write some unit tests to confirm this. I will first move this class into its own file, make it easy to read. And since I already wrote the unit test, so I don't waste your time watching me type it, I'm just gonna paste it in here. Okay, it's very simple. It's 2 lines of code in each test. So, okay, we took care of our first decision maker, which was the parameters in our method. Now, let's move on to the second decision maker and try to extract that out of our method. The second decision maker is the switch statement. I'm going to again use ReSharper to help me extract that out. We'll just extract a method and we call it get entity, and there we have it. Now we've extracted all the logic out of our method. But we did not improve the situation with regards to the testability of the service as a whole. Problem that we have here is that the external dependencies are really tangled in with the logic, and I could not come up with a way to eliminate those dependencies. Well, if I can't eliminate the dependencies, we could try eliminating the logic. One way of doing this that comes to mind right away is subclassing the feed class and letting each subclass know how to get its entities. We could potentially have 3 types of feeds. We could have tweet feed, we could have friend feed, or we can have photo feed. And each of those feeds will know how to get their entities by having a reference to their repos. But I don't like this idea because making each subclass know about its repository will introduce inappropriate dependency between our domain object and its persistence. And potentially this refactoring could affect a very wide area in our codebase. That's not what we want. We want to limit the refactoring as much as possible to this class only. Besides, it really seems like an overkill creating 3 or more subclasses just so that we can eliminate one switch statement. Okay, if we don't want to create subclasses, what can we do? Well, how about we use something that has already been tested and we don't even need to test it ourselves. Here is an idea. Now we can completely remove the switch statement simply by doing repositories feed dot type id dot find by id item id. Feed dot item id. This will return us the correct entity. Okay, and now we can remove this whole switch statement. Okay, let's make this var here. What we did here is move all the logic from our own method into the dictionary class. And since we know that Microsoft has tested it, we don't need to write our own unit tests, confirming that passing the correct key will return the correct value. Now, since there's no decision making going on here, we can simply write an integration smoke test that will confirm that our method does what it's supposed to do and leave it at that. But hold on a second. What would happen if we were to add another NSN type enum value and we forget to add a repository for it here? And if we pass a feed with that new NSN type, we will get a runtime exception saying that the dictionary does not contain an element with that new key. No test will catch this scenario. Before we make this call here, we need to make sure that every possible NSN type has a repository added to the dictionary of repositories here. Here is how we can do this. We will create a new what we accomplished with this here now is that if we add a new NSN type and we forget to add a repository for it here, once the code in our smokescreen integration test hits this line, it will throw an exception and it will let us know that we need to add that new type into our repositories dictionary. This is good, I like it, and for purposes of our discussion would suffice, but there's an even better way of doing it. In fact, there are a few ways we could make this better. To avoid registering the repositories every time we call our method, we could move the initialization and populating the dictionary in the services constructor. Or another way would be to make the getEntity method a lazy loaded property. But the best way, I think, is using an inversion of control container. We could register our repositories in that container using the NSN types as a retrieval key and simply use our IOC container instead of this little dictionary here. I think this is the best way because if you think about it, the knowledge of which repository to use for which type does not really belong in our service here. It is an infrastructure concern, and as such, it should be handled by the application's infrastructure. An IOC container, being a part of an application's infrastructure, is the perfect candidate to hold this kind of knowledge. We could even move this method here into our application's initialization. As you see, there are many ways to skin this cat, but I will stop here because this video got way too long as it is. The main point I wanted to make, and I hope it could get through in this video, is if we want to have unit tests that are easy to write and easy to maintain, we must try and keep external dependencies out of the decision-making parts of our code. I know I did not invent this principle because it has long been the core of domain-driven design, but for people not familiar with DDD, it could be easier to think about code in terms of orchestrators and decision makers. It certainly is for me. With that said, I'd like to thank you for watching. And if you have any questions or you would like to leave a comment, visit my blog post. The link is in the video description below. Thank you again for watching and have a nice day.